What happens when a multi-ton jet flies directly into a massive thunderstorm? Does the water completely destroy engines? Engines actually use special designs to spin water away. Oh no! Look at that heavy rain! Won't it flood the engines a plane fall? Don't worry. Airplanes are built like tanks. Those wings are perfectly smooth, meaning but the engine is swallowing gallons of water. Watch the spin! Centrifugal force flings the heavy water outward. Water exits the sides, while pure air feeds the core fire. And all the electronics are completely waterproofed. Yep, they endure brutal water blast tests before they ever fly. So enjoy the ride! Hey, look up! How do giant airplanes stay up in the air without falling? It's actually pure physics. Let's look closely at this model's design. Wow! Just imagine scaling this tiny model up to a passenger jet.
Whoa! So whether it's a small toy or a giant commercial airliner...
The exact same rules of aerodynamics apply? Look at the engines! They act like massive, high-powered vacuums, pulling huge amounts of raw air right into the front intake. Whoa! The engine compresses that air, mixes it with fuel, and ignites it to blast a powerful stream of thrust out the back. Wow, that force is massive! So that's when the magic happens? It's all about the wings. Air travels faster over the top curve. Higher pressure below pushes the plane up. That's the magic of lift.
The big picture, the 4 forces of flight. An airplane stays in the air by balancing 4 natural forces. Think of it as a 4-way tug of war. Thrust, the forward force that moves the plane ahead. Drag, the backward force, air resistance that tries to slow the plane down. Lift, the upward force that holds the plane in the air. Weight, the downward force, gravity, that pulls the plane toward the earth. 1. How thrust is made, moving forward. To get into the air, the plane must move forward very quickly. This is done using powerful jet engines. Air intake, the giant fan at the front of the engine acts like a massive vacuum, sucking in huge amounts of air. Compression, inside the engine, the air is squeezed tightly into a small space. Combustion, this squeezed air is mixed with jet fuel and ignited, creating a super hot high-pressure explosion. Action and reaction, the hot air violently blasts out of the back of the engine. Because the air shoots backward, it pushes the entire airplane forward. Newton's third law of motion. 2. How lift is made, going up. Once the plane is moving fast, its specially shaped wings take over to push it upward into the sky. The airfoil shape. If you cut a wing in half and look at it from the side, it has a curved top and a flat bottom. This shape is called an airfoil. Splitting the air. As the plane zooms forward, air splits around the wing. The air going over the curved top has to move much faster than the air passing under the flat bottom. The pressure difference. Fast-moving air creates low pressure, it pushes less, while slower-moving air creates high pressure, it pushes more. The upward push. Because the pressure underneath the wing is much higher than the pressure on top, the air underneath physically pushes the wings upward, lifting the heavy plane into the sky. Graph. How speed creates lift. The amount of lift a wing generates depends heavily on how fast the airplane is moving. As the plane speed, airspeed increases, the lift increases even faster. 3. Weight and drag, the opposing forces. To stay in the air, the plane has to fight against 2 natural limits. Weight, gravity. Gravity is constantly pulling the metal structure, passengers, and luggage down toward the ground. The wings must create enough lift to beat this weight. Drag, air resistance. Air feels empty, but it is full of microscopic particles. When a plane flies through them, they push back against the plane, acting like brakes. The engines must create enough thrust to overcome this drag. Summary, how it all balances out. During takeoff, the pilots rev up the engine so thrust is greater than drag. As the plane speeds down the runway, lift becomes greater than weight, causing the plane to climb. During cruise, level flight, once the plane reaches its destination altitude, the forces balance perfectly. Thrust equals drag, the speed stays constant, and lift equals weight, the altitude stays constant, letting the plane glide smoothly through the clouds.
Tracing a line across the afternoon sky. How does a thing so heavy learn to fly? It's a beautiful kind of weightless logic, a secret in the wind of physics magic. And that feeling is the best part, worth knowing, yeah. Yeah, that feeling is the best part, worth knowing.
Thank you so much for watching our animations. If you loved our fantasy, please hit that subscribe button.